In this video, we'll be discussing methods to find the surface area of a solid of revolution. We'll explore how to set up and evaluate the surface area integral when a function is revolved around an axis. As it can be seen, the function can be revolved around the x-axis and the y-axis. Each situation has its own formula, as it can be seen on the screen. For the first condition, when the function is rotated around the x-axis, we have s equal to integral from a to b, a and b being the points of limits, 2 pi f of x, that is a function which is being revolved around the axis, and square root of 1 plus f dash of x the whole squared. F dash of x is the first derivative of the function. Similarly, we have the formula for a function revolved around the y-axis. As we know, a solid of revolution is created by rotating a curve around an axis. To find its surface area, we sum up the lateral surface areas of infinitely small cylindrical slices. The clip on the right shows the function sine of x rotated around the x-axis. As described earlier, this particular solid is split into cylindrical slices, and the surface area of each cylindrical slice is calculated and summed up in order to find the total surface area of the solid. Now let's find the surface area of the function f of x equals x cubed from a to b, that is 0 to 2. To begin with, we have the formula of the surface area of a solid by revolution around the x-axis. According to our question, we have f of x equals x cubed. We need f dash of x, so that's the first derivative of our function, which is given by 3x squared. We have a equals 0, e equals 2. Substituting all of this into our function, we have 0 to 2 integral 2 pi x cubed square root of 1 plus 3x squared the whole squared dx. So we have, on simplification, we have 2 pi x cubed 1 plus 9x to the power 4 dx. Now we'll have to use the method of substitution to solve this particular integral. For that, we can use u equals, I'll be substituting this particular function inside the square root. So I have u equals 1 plus 9x to the power 4. I need du over dx. I'm going to differentiate this with respect to x, which gives me 9 times 4 times x cubed. So that's 36x cubed. Now to substitute du into this, I have x cubed dx. So that's du over 36 equals x cubed times dx. I'm going to plug that in. So I have 2 pi x cubed dx is du over 36. And we have root u, which is u equals 1 plus 9x to the power 4. Now we also have to change our limits because we've changed the variable from x to u. So we have when x equals 0, u is equal to 1 plus 9 times 0, which gives us 1. So there's 1 down there. And then when x is equal to 2, we have u equals 1 plus 9 times 2 to the power 4, which gives us 145. And we put that there. Now to calculate this integral, we can use the standard formula. Before that, I will simplify it further. And that gives me u to the power 3 over 2 and 3 over 2 in the denominator. It's 1 and 145. I can take this out because it's a constant. So pi over 18 times 2 over 3. And I get pi, that's 9, and then 3, so that's pi over 27, 145 raised to the power 3 over 2, and 1 to the power 3 over 2.